Hi friends, so today in this video I am going to show you how to solve the line problems. So that is projection of lines. So for that let us see how to do this. Okay, so this video you need to watch till the end so that you will get a clear picture of how to project the lines. Okay, so go for Solid Edge ST7 software, select isometric draft. So once you select this, the first thing we need to do is a sheet setup. Go for sheet, select A4 sized sheet, switch off background, save it as default, click OK, then fit. So after this, let us see the problem. A line AB 80 mm long has its end A 20 mm above HP and 30 mm in front of VP. It is inclined at 30 degree to HP and 45 degree to VP. Draw the projections of the line and find apparent lengths and apparent inclinations. So this is the problem they have given. So that means there is a line which is AB and they have given the line length which is 80 millimeter. So that line is the 80 millimeter length. So that indicates the true length of the line AB. And one end, that is A, which is 20 mm above the HP. So HP means horizontal plane, and 30 mm in front of VP. So that is 30 millimeter in front of the vertical plane. So it is inclined at an angle of 30 degree to the horizontal plane and 45 degree to the vertical plane. So in this case, you need to draw this projection. So as we know, so it is in the first quadrant, and always we used to solve the problems in first quadrant for especially projection of lines. Okay, so line is 80 mm. Okay, and point A is 20 mm above the horizontal plane, as I have already explained, and 30 mm in front of VP. So it is very clear in this problem, and 30 mm in front of the vertical plane. Okay, now as you can understand the statement, the first thing is we will go for the sketching. Select the line command, continuous line, thickness of XY line is 0.15 millimeter. Okay. So draw the XY line approximately at the center of the sheet and leave some space to write the annotations. Go for annotation, select text, write this as X and this one as Y. So above the XY line it is vertical plane VP, and below it is HP, that is horizontal plane. So let us increase the text size so that it is clearly visible for you. So now I am increasing this to 5 millimeter. So after this, go for the option called offset. Select the XY line, distance, enter the distance as 20 millimeter. It is 20 millimeter above the horizontal plane. Click and right click. Then select the XY line again. Now enter the distance as 30 millimeter. It is 30 millimeter in front of VP. Now going for the select tool, just place the dimensions one side like this, and these two lines are locus lines. Let us convert these lines into a locus lines. Select the lines, these two lines, go for line type, select locus line like this. Okay, now go for annotation. Let us write this as, what is this? This is locus line, that is A, locus of point A. This is also same, the bottom one, that is 30 millimeter in front of VP. Let us type the same, locus line A. So after this, let us go for line command, select continuous line. Now 0.05 mm thickness line. Let us draw the top view of the line. True length is 80 millimeter and the angle they have given it is 45 degree. Let us enter minus 45 here because it is down. Okay, go for angle between command. Let us give the angle between these two as 45 degree, which I have already given. Again go for the line command. Now select the locus line, thickness of locus line is 0.15 mm. Now draw the locus line on the other end of the line, which is point B. Okay, same thing, we'll go for the line command, which is 0.05 mm line, continuous line, and project this upward so that we will get the front view 80 mm and the angle is 30 degree. Okay, so we will get the another end here. Again go for the locus line. Okay, let us give the angle between, let us mention it as 30 degree, which I have already explained. Now go for the line, select locus line. Locus line is 0.05 mm, sorry 0.15 mm. Okay, now draw the locus of B. Okay, as you can see, just go for text. Okay, now let us write this as A, this I can mention it as B2. Okay, let us call this as, this is the front view, let us take this as A dash, and this one I will mention it as B1 dash. Okay, now go for text again, let us call this as locus line B. Okay, where the point B lies, the same thing, so this is also locus B. So after this, let us increase the text size so that it is clearly visible for you. Now selecting all the text, let us increase this to 5 millimeter. Okay, I think it is visible now. Now go for the line command again, continuous line. Now 0.05 mm, it is a projection line thickness. Now project from top view to the front view, that is A to A dash. Okay, in the same case we will project it from B2 to until it crosses the locus line A. Okay, then same case B1 dash to until it intersects the locus line A here downward. Go for trim option, trim, this is the extra projection line and this is also not required here. Okay, I will trim it. Then go for arc by center point, keeping, let us see, arc by center point, keeping A as a center and this point, let us name this so that it is easy for you to understand. Let us, I will call this as B1. Okay, enter B1 and I will call this as B2 dash. Okay, and let me increase the size to 5 millimeter. Now it is visible. Okay, so go for arc by center point, keeping A as a center and B1 as the radius. We'll draw the arc and that arc should intersect this locus line B like this. Same case, A1 dash as a center, B2 dash as a radius, and we'll draw the arc like this. This is the extra portion we don't want. Okay, go for trim option, we'll trim this. Same case here, and we will trim this extra projection. So after this, go for the line, continuous line. Now we need to draw the visible line. It is 0.5 mm thickness from A to this intersection of this curve or the arc, from A dash to this end of this arc. Let us name that as let me go for the smart dimension and give this as a true length, it is 80 millimeter. Okay, and they have asked you to draw the projections of the line and find apparent lengths. As you can see, apparent lengths means go for smart dimension, let us measure it. This is apparent length in case of front view and this is the apparent length in case of top view. Okay, so after this let us go for angle between, because they have asked apparent inclinations. Okay, so let us measure the inclination of these lines. Go for angle between, the angle between the locus of A and this line, it is 45 degree, and angle between locus of A and here with respect to VP it is 55 degree. So that we need to write here. Go for text, write the results here. Okay, as we know, line A dash B dash, which is equals to As we have already know, it is 56.57 millimeter. Okay, that you can see here, 56.57 millimeter. Okay, and in the top view it is 69.28. Okay, that is line AB is equals to 69.28 millimeter. So these are the apparent lengths, and let us indicate the apparent inclinations. So with respect to HP it is 45 degree, so that we call it as alpha. Go for insert character, select alpha. For that select symbols, select alpha. Okay, then equal, then for 5 degree, select it, copy it, minimize it and paste it here. Okay, then same thing, now erase these things. Now go for beta, select it, is equal to 55 degrees, the angle made by the line with respect to VP, it is 55 degree. So this is how you need to draw the projection of line, so particularly for this problem. And let us mention this as A dash. This is the apparent length in the front view, and this one as B, that is AB is the apparent length in case of top view. Let us increase the text size here. Let us select all the text and will increase the size, so which I have already increased some of the texts. Let us try to increase, and I think it is not possible to increase, not required to increase all the text size, because we have already increased some of the texts into the 5 millimeter size. So let us increase only the text which are not visible. Okay, so let us select only B dash, and this A dash or this B, and these lines. Okay, make it to 5 millimeter. Now it is clearly visible. So this is how we need to solve the projection of line problems. So let us go for 0.05 mm projection line, and always remember the points B and B dash should lie in the same line. As you can see here, the cursor, B and B dash are in the same line. Then we will go for the leader, so that we will show the direction of projection. We have projected from A to A dash, and here we have projected from B1 to downward, so that is like this, and here it is clockwise. In same case here B2 to upward and B2 dash to counterclockwise, like this. So this is how we need to solve the points problem whenever they have given. Let us see, this is the front view of that line, and this is the top view of the line given. So these are the results, apparent lengths and apparent inclinations. So this is how we need to solve the line problems. So if you are newcomer to this channel, and if you want to learn more, and if you want to see such type of videos in future, click the subscription button just below this video. Click on the subscribe button, and if you like the video, just hit the like button. And if you want any particular video regarding in case of projection of points or lines or any type of engineering graphics videos, just comment in the comment box. Okay, and don't forget to press the bell icon so that you will not miss any video in future. Thank you for watching. Thanks a lot.